Welcome back to Calculus 3. In this part, we are going to study section 3.4, motion in space. If you recall in the topic in chapter 3, it's about vector-valued functions. And we talk about two kinds of vector-valued functions so far, in the two-dimensional case and in the three-dimensional case. Actually, I'm just going to say, this is a two-dimensional vector-value function, right? And that is a three-dimensional vector value function. But anyway, in each case, it represents a curve. And also, usually we use variable to denote use t to denote a variable. The actual meaning of t, we say t is a parameter, and many times t has an actual meaning. T it is for time. I'm saying imagine the situation at a different time, because at a different time there's an ordered triple, right? That is the point in the three-dimensional space. So at a different time, at a different point. So such a vector value function can be used to track the motion of an object. So indeed, I don't want to go through all the details. I just want to tell you the general conclusion. Motion in space, in the three-dimensional space and in the two-dimensional space, just about the same. Okay, I'm using the example as for the three-dimensional case. So we are having a vector value function because it is a curve. So we can use this curve to trace the motion of an object. And if that is the case, we can consider such a vector value function as a position function. And then if this is the case, then we know when you have a motion, there's a velocity. The velocity, it turns out to be the derivative of the position. And also the acceleration, it is the derivative of the velocity, which turns out to be the second order derivative of the position. I say this should be very simple thing, right? Motion in space. If you are having a position function, and then you can figure out the velocity by taking the derivative of the position. And then the second order derivative of the position, it is for the acceleration. Another small thing worth to mention, I hope you can tell the difference between velocity and the speed, right? Velocity, it is a vector, which means it has a magnitude and direction. Because I hope it makes sense to you. Well, when we talk about motion, you move left to right, south to north, all those kind of things. You need to have a direction. Okay. And the speed, it is just the magnitude of velocity. So you will see how we handle velocity and the speed in the next example. The example I'm having here, again, it is taken directly from the textbook, checkpoint 3.14. We are having the position of a particle, and the curve path, it is defined by this vector value function. We want to find out the velocity, acceleration, and the speed as functions of time t. So the velocity, as we just said, it is a derivative of the position. Derivative of vector valued function, as we mentioned earlier, you take the derivative of each component. Still, that's forming a vector. Okay, they are all forming a vector. And so derivative t squared minus 3t just tend to be 2t minus 3. Derivative 2t minus 4, there's only 2 left. T plus 2, that's 1. And that is the velocity. I hope it makes sense. At a different time, the velocity is different because it may move into a different direction at a different rate. So that's a velocity. A velocity, it is a vector, okay. Acceleration, it is a vector too. So the acceleration, it is a, well, actually, I don't know. I forgot the double order, second order derivative, double prime here. Double prime. The acceleration, it is the rate of change of the velocity, or the second order derivative of the position. So you take the derivative of the velocity. 2t, it is given 2, and 2 is given 0. and one that tends to be 0 too. So the acceleration turns out to be constant. Turns out to be a constant, okay. Turns out to be constant. Well, it is, I should say, a constant in a fixed direction, And then finally, about the speed. The speed, it is the magnitude of the velocity. So when you take the magnitude or the norm of the vector, you take the square root of the sum of squares of the components. So this turns out to be the speed function. I hope I got it correctly, right? 2t minus 3 squared plus 2 squared plus 1 squared. So when you expand it, 4t squared minus 12t, and this will be plus 9, and plus 2, plus 4, and plus 1, so that's plus 14. So that is the topic I want to cover in section 3.4, motion in space. Thank you for watching.